Hello everyone, welcome to my channel. In today's video we have this given, what shall we say, radical equation or exponential equation. Alright, so we have the cube root of 2 to the power of x equals the x root of 9. And we're going to solve for the values of x, or the real values of x. So, how do we solve this equation? Do we see a common base for both sides of the equation? This is base 2 and the other one is base 9. That's on the right hand side. So we're using the laws of logarithm to find for the values of x, since we don't see a common base for both sides. Alright, so how do we apply the laws of logarithm on this equation then? Can we do the logarithm of both sides of the equation right at this time? The first step? Not so fast, right? So what are we going to do then? Is to rewrite the left and the right hand side of our equation. And so this means that we're converting the radical sign into exponential form, right? So we have the left hand side now written as 2 to the power of x over 3, right? Since the cube root of a number of x is written the same way as x to the power of 1/3. Okay. So now our right hand side is written the same way as 9 to the power of 1 over x. Or the right hand side can be written also as 3 squared. Since 3 squared is 9, then raised to the power of 1 over x. And this way, the right hand side further simplified as 3 to the power of 2 over x. And the left hand side remains the same, 2 to the power of x over 3. So now then we can use the laws of logarithm now to solve for x, right? So we take the log of both sides of the equation. Log of 2 to the power of x over 3 equals log of 3 to the power of 2 over x. And so now we apply the power rule of logarithm, whereby the exponent, we're putting that on the side to the front, right? So that is from the formula. If we say we have log of a to the power of b, this is written the same way as b times log of a. So we're using this formula to our equation. Alright, so our equation now becomes x over 3 times log of 2. And the right hand side is 2 over x times log of 3. So from here, combine the variable and the constant to one side. So variable on the left side and constant on the right side. So we have x times x, right? So that is x squared equals 2 log of 3, 2 times log of 3 times 3 divided by log of 2. So we have x squared equals 2 times 3 is 6 times log of 3 divided by log of 2. So solving for x, we take the square root of both sides of the equation, right? So it's square root of x squared, and the right hand side is square root of 6 times log of 3 divided by log of 2. And here the radical sign and square cancel. So now we have x is equal to positive negative square root of 6 times log of 3 over log of 2. So this is now our answer. We have two answers, positive negative, the square root of 6 log of 3 over log of 2. And from here we can find the value in numerical form. That is, if we use our calculator, it's approximately equal to positive negative 3.08379. So we have here the exact value of x, and this is the approximate value of x. And so now let's check our answers. Alright, so substitute the value of x to our original equation, or shall we say the simplified form of our original equation. So here is our original equation, and we simplified it to this equation. So we'll be using this simplified equation to check our answer. Okay, so let's take this equation. So we have this equation, so let's check. So 2 to the power of x over 3 equals 3 to the power of 2 over x, and our x is approximate value 3.08379 to 5 decimal places. So we have 2 to the power of x over 3 is equal to, so here x over 3 is 1.02793. So 2, 4, 5, so 5 decimal places. Is this equal to 3 to the power of 2 over x, where 2 over x is 0.64855. So here, our left-hand side to the power of 1.02793 is approximately equal to 2.03909. And is this equal to the right-hand side? 3 to the power of 0.64855 is approximately equal to 2.03909. So these are equally the same. And this is substituting the value of x, that is positive. So from here, positive 3.08379. Let's do the negative. So substituting the negative value of x, we have here 2 to the power of x over 3, and here x over 3 is equal to 1.02793, that's approximately, and we have the value of x here is negative, so this turns out to be negative, right? So this will be 2 to the power of negative 1.02793, and is this equal to 3 to the power of 0.64855, and this turns out to be negative 2, so that's negative 0.64855. The left hand side, 2 to the negative power, we have 0.49041. Is this equal to the right hand side? 3 to the power of negative 0.64855 is approximately equal to 0.49041. So these are the same. And so we have now confirmed that our values of x that we got are correct. And so that's all for now, and thank you for watching. I will see you in the next one. Have a great day, everyone. Take care. Bye-bye.